Hello everyone, welcome to our week 10 lectures, which will be the last week for our CSC281 before we delve into the final project. This week, we're going to be taking a look at the wrapper classes for primitive type, abstract classes, and then polymorphism. Now, to get started with wrapper classes, you've seen these a few times, but we just want to make sure that we review what these concepts are. So in general, every primitive type inside of Java is wrapped with this more advanced type, which is the wrapper type essentially. So for instance, an int can be an integer, a double is referred to as a double as its wrapper, boolean, and so forth. And you'll notice the reason that we have to wrap these is so that we can get access to the toString methods, the overloading methods, and to make them work with ArrayList. Now, it is important since generic classes can only be instantiated using objects and not primitive types. This is why we have to wrap these as well. And the easy thing here to remember is that conversion between primitive types and their corresponding wrapper types is automatic. Now, the process of converting a primitive type to a corresponding wrapper object, so essentially from an int over to an integer or a double to a double with a capital D, is called auto-boxing. Now, a wrapper can be unwrapped. Essentially, a double can be unwrapped to a double like so, a character to a car. And that is the process called unboxing. So we're just going to quickly take a look at this ArrayList.java file in your week 10 folder. And you'll see here that inside of my ArrayList, I have each of these items created. Oops, let's just, let me restart this real quick. There we go. Sorry about that. Not cooperating. Awesome. So if you go into the ArrayList.java file, you've seen these before when we were using ArrayList in the previous examples, but you could see here that essentially I have this array list of type integer called nums, and it's created as a new array list over here, and then we can just add an integer into it there. So now, for instance, if I was to add in John 10 times in here, you'll notice that I get this error, and it says the method add integer in the type array list integer is not applicable for the arguments of string. So again, in this scenario, we want to make sure that we're only making ints. And the thing is that this doesn't need to be an integer of 10, right? Let's just say integer x is equal to 10 and an int a is equal to 5. We can add a into this integer list, or we can add x into this integer list. So these are actually both capable of being added into it because both of them are integers. And essentially this integer is the same as this int, but it's just more of a wrapped class. And we can use a wrapped class with this array list. Now, if we try to make this an int right here, you'll notice we'll get this error. Syntax error, insert dimensions to complete reference type. Let's try to see if I can put another int over here. That doesn't do it. Maybe we could put one over here too. We'll notice that both times that we tried to do this, we got to insert a dot class. We're getting these really weird errors that we usually can't solve, so that's why we need this wrapper class to solve it. Now, if we go ahead and run this code here, we'll notice we'll get 0, 1, 2, 3, and 4. We get the max out of this nums, and then we could do it here. Exact same thing can be done for an array list of doubles. Let's do characters for the time being. I'll call it CHS, is a new array list of these types. And what I could say here I can go through this 5 more times, and I could say add, and you'll notice here that what I'm adding into it is a type of character. So I can't, I can add in something like this, regular character like an E, and I could say car val is equal to R, something like this one, and then I can also add val into it as well. Cool. Let's call this val2. Great. So this is one way that we could go ahead and put these together. And this is just a difference between what the wrap types are and the unwrapped primitive types are as well.